Hi, it's Jack Mayer, and thank you for watching this video. Today's video is on classical test theory and the notation used in talking about classical test theory. Now, why are we interested in notation? Well, classical test theory, it's a mathematical model, so it involves math and some algebra. Most of the notation involves basic statistical notation you are already familiar with, but there are a few extensions of that notation. Some notation has been developed that's particular to test theory and to classical test theory in particular. So why begin with the notation? Well, notation is cool. It's like learning a secret code. It provides some insight as to what's to come. And last but not least, it's easy to write down a few symbols and their definitions. So long as there aren't too many symbols, you're going to be okay. We're all going to be okay. And plus, I think that there's kind of there's this profound part of notation, which is that it kind of hints at deeper meanings within the mathematical model. Let me explain that as we look at some of the actual notation that's involved. And, well, we'll get right into it. The first thing we see here is an X, and X is going to stand in for an observed test score, the actual score that an individual gets. Okay, so if I take a test and I get 90 at the test, that's my X, it's my observed score. But now let's look at this second symbol, T. Now that's something you haven't seen before in statistics, presumably, at least not standing for this. T stands for a true score. And a true score is a hypothetical construct. It's a measure of a person's pure ability, or their actual attitude, or their special trait. And T implies that X is not T. That is my obtained score, my 90. Let's say that was a 90 on a spelling test, which goes from where most of the students scored from like 50 to 100%. That 90 is that observed score, that X, is not my true score. My true spelling score might really have been 95, or in my case, it's much more likely that it would have been 80 or 85 because I'm not so good at spelling. Hopefully there are no spelling errors in this video. And so there's this distinction in classical test theory, which is lovely, between the score that we get, and the test score that we, in some sense, deserve, the true test of our ability, or of our attitude, or of our extroversion, some trait or another. And one of the things that accounts for the discrepancies between the obtained score and the true score is this E, this error score. That is, there is some degree of that obtained score is a consequence of an error, not necessarily our error, but an error in measurement. That is to say that the psychometrician, the person who uses psychometrics, who uses test theory, the psychometrician has built into the assumption, there's going to be some error here. Okay, so that's X and T and E. Let's take a look at a few more. We've got epsilon, or expected value. And that's a mathematical operator like plus, minus, multiplication, and division. And it's usually set equal to the mean of a set of numbers. In fact, in the old days, I like to go back to old days, like 1910s and 1920s, when people, psychometricians and mathematicians, things just weren't as complicated as they are in modern life. And back then, there was no expected value. They just said that there was a mean, like a summation over n of a set of numbers. So why was epsilon introduced? Well, it's a very, epsilon is basically a mean, an average, that is, of future events. So let's say that I know everybody's height in a given classroom. And I want to predict the height of any one student. And I don't know which student I need to predict. the best predictor of the height of a student is what? It's going to be the mean of everybody's height. So let's say that that's 5 foot 8 inches. Okay, that's the mean. That's the best predictor of a student. But let's say that there are a couple of students who are late coming to class, and they're going to come through the door in a moment, and I want to predict their height. Well, they weren't part of my measurement of the mean initially, because I made my prediction of height based on everybody who's in the classroom already. So without knowing their height, without them being a part of this sample that we took, they are representing future events. I'm trying to predict the heights of these students who are in the future, who are going to come through the door in a few minutes. In this instance, I talk about an expected value. What's the expected value of their height? It's also going to be the mean. But because it's in the future, I don't talk about the mean of the heights of these future students. I talk about their expected value. That's what that is. Okay. And then the last symbol is rho, which stands for the population correlation. Whereas we use R, you probably, well, I don't know if you remember, but R from your introductory statistics class, R was used to designate a Pearson product moment correlation and of a sample. And rho is used to denote that very same correlation, but as it applies to the population, that is to everybody who we possibly might be able to measure. That's it for notation. Wasn't too much there. Now we're going to move into classical test theory itself and take a look at the 5 assumptions of classical test theory. That's coming up next. Thank you very much for listening to the video. If you have any comments or questions, please feel free to contact me.